Good morning. It's a pleasure for us to present this work about microbiota of hypersaline waters, allobaterium, archaeas, and microalgae properties for the skin. Every day we know better the saline's water properties, its characteristic both in the way they are applied to the body as well as in their composition and mechanism of action. We know three escape mechanisms with saline involvement: cellular osmosis, genes transcription translation, and mechanosensitive channel when the piezo channel has a vital importance. We think we haven't not paid the necessary attention to the saline's water microbiota. Indeed, we have considered an hypertonic medium as a limiting factor of life when we know perfectly of the existence of allotherant microorganisms who can live in more than 150 grains of salt by liter of water. We know moderately halophilic microorganism, or in extreme condition the halophilic microorganism who can live in a concentration of 250 grams of salt in 1 liter of water with normality. What types of microorganisms do we know in saline waters, in brine waters? 5 types. Phytoplankton, when the Eucaryota 1 Dunaliella species have a vital importance for the health of the skin. Zooplankton, allotherant bacteria that you know perfectly, like cyanobacteria, or sulfate reducing bacteria who transform to sulfate and hydrogen sulfide in sulfurous lake, and less known the allophilic arches who can produce a pink pigment, who have a special and very strong antioxidant properties, and fungi and yeast. Where do these microorganisms to live and to reproduce? And they make mainly in both anaerobic and aerobic environment that occur usually in the bottom of the estuaries and saline lake by precipitation of minerals and concentration due to the water evaporation. To generate this phenomenon, we had to require some conditions like high solar radiation, high temperature, high saline concentration, a pH around neutrality of the water, and in some times a very thin layers of water in the lake that we know like shallow water or shallow lake. Under this condition, water evaporation originates the ordinary precipitation of mineral. The first of one is the carbonate, calcite, and dolomite, and the other carbonate. is the first mineral who have precipitation when the concentration of water is the 50%. That is, when the evaporation of water is the 50%. The second one precipitate mineral were the sulfate. We need an 80% of evaporation of water to this precipitation. And we have there gypsum, plaster, and anhydrite. And finally, the last one, precipitation due to the chloride salt. Sodium chloride, magnesium chloride, etc., have more than 90% of evaporation of water to have a precipitation. And there we have a silk in the bottom of the lake. The lake have a thin layer of water or a very high layer of water. And this, in every case, we have the silk with two different parts. The surface, when aerobic microorganisms can live, and inside the silk with the anaerobic microorganisms grow and make the microbiota of the saline lakes and saline estuaries. We can see the difference of the deep lakes or the shallow lake with a very thin layer of water. One is blue, we can see orange by the sun, but it's blue, the Dead Sea, and we have here two lakes. One is deeper than the other one. This deep, that is no deep. This is blue, that is pink. Is due to the thin layer of water, and they grow in this condition from archaeas. We can see in a few seconds. As an example of the growth of aerobic microorganism, we have the Dunaliella salina. It's a unicellular microalgae with recognized antioxidant properties, and it's wonderful for the skin, caused by its very rich content in beta-carotene and vitamin B12. This microalgae is now growing to make dietetic supplement. They have antimicrobial and antioxidant properties very interesting for the skin. An anaerobic archaea are capable to produce different molecules, exopolysaccharides, carotenoids, and proteins to adapt to the extreme condition, and a pink pigment with much more antioxidant power than beta-carotenes, 1000 more potent than beta-carotene. In addition, the excellent cosmetic properties serve this pigment as food to flamingos, serve to feed the flamingos birds, which provides the pink color. As a conclusion of the very short work, we can say the salty hypertonic medium has its own microbiota and environment dependent. It's different the deep of the lake to grow different microorganisms. This microbiota has a very important properties in general for dermatologists and cosmetic use that we know. I I would like to show this photograph from the Pink Lake from Torrevieja, Alicante, Spain. Is in the southeast of Spain, and this wonderful image I used to send a greeting to our colleagues from Romania, our friends from Romania, and especially to the Professor Constantin Monteanu to permit to stay here speaking to the Romanian people. Thank you very much for your attention.